This question was asked in the GATE Physics paper 2021. This is a numerical answer type 1-mark question. And this question was asked from the topic quantum statistics. The question is, three non-interacting bosonic particles of mass m each are in a one-dimensional infinite potential well of width a. The energy of the third excited state of the system is x multiplied with h cut squared pi square by m a square. Then the value of x in the integer form is, so we have to find the value of x for the third excited state of this system. In order to solve this problem, we need two important concepts, and they are: first, how are the energy levels located in one-dimensional infinite potential well of width a? And the second thing we have to know is that how are three bosonic particles will be arranged in the one-dimensional infinite potential well energy levels to have third excited state of this system. Now let us see the solution. If you have solved the problem for one-dimensional infinite well having width a in your basic quantum mechanics, then you know the energy spectrum for one-dimensional infinite well having width a is given by En equals to n square pi square h cut square divided by 2m a square, where n is the principal quantum number of this system. So En is the energy of the innate energy level of this potential well. H cut is the reduced Planck constant. M is the mass of the particle in that potential well. A is the width of the infinite potential well. Now, if you put n equals to 1, then the energy for the ground state, that is the first energy level, is given by pi square h cut square by 2m a square. So we can write the expression for the innate energy level is n square multiplied with E1. In the previous slide, we have already seen the energy spectrum of the one-dimensional infinite potential well. Now we'll see how can we accommodate the three bosons in the energy levels such that the system has the third excited state. We'll do it systematically. First, we'll find the ground state of the system, then first excited state, then second excited state, and finally we'll find the third excited state of this system. One important information regarding the boson particle is that there is no restriction on the bosons to be accommodated in a particular energy level. Hence, for the ground state, all the bosons will be accommodated in the ground state energy level, that is n is equal to 1. For first excited state, two bosons will be in the energy level n equals to 1 and remaining one boson will be accommodated in the energy level n equals to 2. For second excited state, one boson will be in the ground state, that is n is equal to 1, and the remaining two bosons will be in the energy level n equals to 2. And for third excited state, the arrangements of the three bosons will be like this. Two bosons will be in the energy level n equals to 1 and the other boson, that is the last boson, will be in the energy level n equals to 3. So this is the configuration of the bosons for third excited state. Hence, in third excited state, two bosons will be in n equals to 1 state and the other boson will be in the n equals to 3 state. Up to this, we already found the actual arrangement of three bosonic particles in the energy levels of one-dimensional potential well to achieve the third excited state of this system. Now we will calculate the total energy of the three bosonic system having third excited state. So in the third excited state, two bosons will be accommodated in the ground state energy level, that is first energy level, and the remaining one will be accommodated at the third energy level. So the total energy at the third excited state will be 2E1 plus E3. Now if we put the value of E1 and E3, it will be 2 multiplied by pi square h car square by 2ma square plus, and for E3 it will be 3 square pi square h car square by 2ma square. So that is 9 multiplied with pi square h car square by 2ma square. If we add this, then it will be 1 plus 9 by 2 multiplied with pi square h car square by ma square. After adding this, we will get 5.5 multiplied with pi square h car square by ma square. So this 5.5 is your x, but we have to write the x in the integer form. So the nearest integer for 5.5 is this 6. So your x value will be 6 in the integer form. So for this numerical answer type question, the final answer is 6.